5, 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1.
With the recent success of NASA's first uncrewed Artemis mission to the moon, work has been quickly accelerating to develop long-term solutions to supporting human activity on the lunar surface. Flight testing of the SLS and Orion spacecraft is a huge milestone, but that's just the first step in a very complex plan to establish the first permanent settlement on the moon. NASA's game plan for the Artemis program is in a constant state of evolution as they bring in more private sector partnerships to help with the development of future space exploration technologies. Obviously, SpaceX has a major part to play with their human landing system Starship, and we've also recently seen plans come to light for infrastructure like pipelines and roads on the moon, 3D printed habitats, and a new generation of extravehicular spacesuits. So, let's catch up on NASA's new plan for their first moon base. This is the space race. We know that the first human return to the moon is going to happen on NASA's Artemis 3 mission, which is optimistically scheduled to happen as early as 2026, and more recently, NASA has confirmed that they intend to achieve a second crewed landing with Artemis 4 as early as 2027. Both of these excursions to the lunar surface will be completed using a variation of the SpaceX Starship, the Human Landing System. For both missions, this lander will serve as a base of operations for 2 astronauts on a 5-day duration. This will far exceed the standing record for the longest stay on the moon, which was 75 hours for the Apollo 17 crew in 1972. Luckily for NASA, the Starship's 9-meter diameter hull and towering height will make for a comfortable and spacious living quarters on these early explorations. But just living in the Starship isn't a long-term solution for establishing a permanent human presence on the moon. They need a real plan to build infrastructure for the next decade of Artemis missions, which will eventually see a crew of 4 astronauts living on the moon for up to 1 month at a time. NASA Associate Administrator Kathy Lueders has promised that on each new trip, astronauts are going to have an increasing level of comfort with the capabilities to explore and study more of the moon than ever before. Lueders wrote in a statement, quote, "With more demand for access to the moon, we are developing the technologies to achieve an unprecedented human and robotic presence 240,000 miles from home. Our experience on the moon this decade will prepare us for an even greater adventure in the universe, human exploration of Mars." In January 2023, NASA announced a new plan to lay pipe on the moon. The Lunar South Pole Oxygen Pipeline would become the first permanent human infrastructure to be installed up there, and this would be a major first step towards establishing in-situ resource utilization. The idea of the pipeline is to transport high-purity oxygen from a production source to a storage plant located near the future moon base. NASA has already developed a process that they call molten regolith electrolysis, or MRE, which they will use to extract specific elements from the lunar dust, which has a large amount of oxygen already stored in it. The oxygen will be used for supplying human habitats, pressurized rovers, and even to serve as oxidizer propellant for launch vehicles departing the moon. The reason that NASA wants to build a pipeline is that the energy required to move the stored oxygen around the surface on rovers would actually be more intensive than the energy required to extract the oxygen in the first place, which would make the entire process unsustainable. So, NASA is proposing a 5-kilometer-long pipeline to transport oxygen gas on the moon. The pipe material itself would be manufactured robotically on the moon using in-situ aluminum metal obtained through MRE. NASA has a plan for a fully automated machine that would extrude the aluminum into a pipe shape, like the same way you make rigatoni pasta. This pipeline would support a flow rate of 2 kilograms of oxygen per hour and could supply a moon base with up to 10,000 kilograms per year, which is the amount that NASA is projecting will be required for a self-sustaining base. These oxygen extraction technologies are planned to be demonstrated at large scale on the moon as early as 2024 and provide direct support to Artemis astronauts as early as 2026. In November 2022, NASA awarded a $57 million contract to develop a lunar surface construction system. The recipient of that money is ICON, a leader in advanced construction technologies and large-scale 3D printing. In 2018, ICON accomplished the first fully 3D printed house in the United States. In 2021, ICON began work on Mars Dune Alpha, a 3D printed habitat at the Johnson Space Center in Houston, Texas. The 1,700 square foot structure simulates a realistic Mars habitat that NASA astronauts will use in training missions as they prepare for long-duration trips to deep space. Project Olympus is ICON's latest move to research and develop space-based construction systems to support planned exploration of the moon and beyond. ICON's Olympus system is intended to be a multi-purpose construction system primarily using local lunar and Martian resources as building materials to further the efforts of NASA to establish a sustained lunar presence. The idea is to use the lunar regolith and melt it into a cement-like base that can be laid down by a fully automated 3D printing robot. NASA has actually provided ICON with samples of real moon dust that were collected during the Apollo program to help them develop their manufacturing process. The regolith will mix with a resin-like chemical that can be cured and hardened by UV radiation from the sun, which is actually the same process we use to cure dental castings for your teeth. The first tech demonstration for Project Olympus is set to happen as early as 2026 and would mark a giant milestone in human civilization, our first constructed habitat on another world. ICON is also developing an infrastructure system for the lunar surface that would include roads and landing pads. These are more important than you might think. One of the greatest impacts of human activity on the moon's surface will be kicking up dust, massive amounts of dust. It's been estimated that the force exerted by the engines during a Starship landing on the moon could kick up 1 million pounds of surface particles, and similarly, driving around in rovers and pressurized habitat vehicles will stir up a lot of surface dust as well. So, to minimize our impact on the natural environment of the moon, it's actually much better to lay down solid landing pads and roadways. Utilizing those new roads on the moon will be the next generation of lunar rovers. The Lunar Terrain Vehicle, or LTV, is scheduled to arrive on the moon following Artemis 3, possibly as early as Artemis 4. The design is pretty similar to the side-by-side ATVs that are commonly used for hunting and farming. The rover could be driven by an astronaut behind the wheel or remotely controlled. NASA is even experimenting with the possibility that this could function as an autonomous vehicle. This also means that NASA can use the LTV to continue to conduct scientific or mission-related work even when no humans are on the moon. The LTV is going to be critical for searching out water, ice, and other lunar resources, which will in turn help NASA select the best site for the more permanent elements of the base camp. Going one step further will be NASA's Habitable Mobility Platform, which would be the first pressurized rover vehicle with an independent life support system. That means astronauts wouldn't have to wear spacesuits to operate the vehicle and could spend hours or even days on excursions into the lunar landscape. The HMP is scheduled to arrive on the moon sometime between Artemis 5 and 8. The development of new spacesuits for the Artemis program has actually been one of the biggest concerns for achieving the goal of returning humans to the moon. While NASA debuted their next-generation spacesuit concept several years ago, they ran into major troubles with actually getting them manufactured at a reasonable price in the timeline required. It got so bad that the old suit design had to be scrapped entirely and replaced with a new spacesuit that NASA has contracted out to Axiom Space, a private American aerospace company. NASA awarded them $228 million in funding to pick up the fumble and have a moonwalking system ready to go for Artemis 3. This contract was awarded in September 2022, and the new concept design is expected to be released for the first time in the spring of 2023. These new extravehicular suits will have to be totally different from the design that we have grown familiar with seeing on spacewalks at the ISS. A lunar mobility suit has to stand up to the gravity of the moon and resist the incredibly sharp and abrasive dust that the astronauts will encounter there. Back in the Apollo era, astronauts who walked on the moon had trouble with tiny shards of lunar regolith actually penetrating their suits and causing irritation. Since there's never been liquid water on the moon, the rocks up there aren't smooth and round like the ones on Earth. They are incredibly sharp and jagged. Watching all of these projects come together over the next decade is going to be pretty spectacular. The future of humanity as a multiplanetary species is being built right now, one step at a time. But what do you think a habitat on the moon is going to look like in the future? Drop your theories in the comments down below. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.